We've learned before about how H2O molecules end up having a partial negative on one side and a partial positive on the other. And this causes it to sort of have a chain reaction and make a lattice structure. And that allows some molecules to fit into the lattice and some molecules not to. So one thing that would not fit into the structure is a group of carbons in a row that are attached to hydrogens. And I'm not sure what this is called. It's a lipid or something like that. I'm not a chemist, but I want to show you something that I think is really neat about our bodies, something that should be said. Okay, so we have this part that doesn't like to be in the water. So this section of it is hydrophobic. Hydrophobic. And, hydro means water, and phobic is like a phobia. That means it doesn't like to be in the water, or you could say it's afraid of water. And then this could be attached to something like this. And because of the oxygens hanging off, this will have little partial negatives around, and then it will be able to fit into the structure. It'll be able to attach here or here, maybe both. This could be, whoops. I moved my screen. There. This section, if I'm able to draw, this section could be a zoomed up version of this. I don't know if it would fit quite that nicely, but you see it has negatives, and so it would be able to fit in, or it has partial negatives, so it would be able to make little weak bonds with the hydrogens around. And then this part has no partial negatives or anything. It's just balanced, and so it's hydrophobic. And this part is hydrophilic. I think that's how you spell it, hydrophilic. So that suffix means it loves to be in water. So the interesting question about this molecule, well, actually, I'm going to branch off. I meant to get orange. I'm going to branch off and say that there's another one of these, just this copied. I'll draw it this way, I guess. What do I have? 5, 3, 4, 5. Okay, and then this has all the H's also. And so the interesting thing is we're going to say what happens when this gets dropped into a bucket of water, or a whole bunch of them get dropped in. And my first thought about this molecule was that they would, I'll just draw you a picture. If you have, pick an interesting color. There. If you have a beaker of water and you dropped in a bunch of these, that's ripples on the top. I was thinking that they would have their tails sticking out, and that the heads would be in the water, because that would make sense. The head loves water, the tails don't, and I thought maybe they would be rigid enough to stick out of the water, but I don't think they do. What actually happens, I need a bigger beaker for this, is that they will sort of group together, and the heads will be on the outside, and it'll sort of make a ball like that. I'm just drawing a cross section of it. It would actually be a sphere all the way around, and then all the little tails would be pointing into the middle. And so then, again, it makes sense, because this part, the head loves water, and so the head is being exposed to the water that's in the beaker. And the tails don't like water, and so they get to group together on the inside and have just touching each other, not touching the water whatsoever. But the more interesting thing that happens is if they get organized correctly, I'll pick yet another color, and I need yet another bigger beaker, is that maybe, if they get organized right, they can make a bilayer. Which, well, I'll draw it this way first. I might show you another way in a second here. is that the heads will sort of make this donut shape around. I'm going to have to get lazier of drawing or this is going to take forever. Okay, so you have two layers, and on the inside the tails go this way, like that. I'm drawing them kind of short. And on the outside the tails go to the inside, and I mean they're pretty long. I think they would take up most of the space. They'd be like that. And so you can see now there might be water on the inside here. This is water, and outside is also water. And then, you know, the tails, again, it's just like this, but just with two layers now. The tails don't have to touch any water. They're hydrophilic, and so they don't want to, and then they just make this little ring on the inside, and there's water separated from other water. If we kind of zoom in on it, like these are hugely drawn, you know, they would actually be really small. And I'm just drawing a little cross section of it. This is more like the scale that you would see, I think, is just a little bit like that. And then the other layer over here, very close together to not allow any water through. And it's not like water's going to sneak through, it's just that, you know, they're hydrophilic. And so then you can have water on this side that's different from the other water on this side. I just drew it green to show that it's not mixing. In our little zoomed in square, I picked black. I can't draw black on black. In our little zoomed in square, it's separating the water. It's the membrane that protects the inside of our cells from the outside. And that's where this becomes useful. This is the bilipid layer. Bilipid layer. So I just think that's just amazing that our body, that you know, just chemistry can give us walls to our cells, and anything that is water soluble, you know, any kind of ions. If we have ions on the outside, they aren't able to cross this barrier, but some things are. They're selectively permeable. P. Just start writing that over again. Permeable. And so it allows some things through, but not others. And generally anything that's soluble. I'm having trouble with that word. Anything that is that's broken up in the water won't be able to pass through because the water can't pass through, but other things can. And they can even. Oops, I'm going off the screen. They can make sort of a fixed gate for things to pass through. If I can draw this, you know, imagine that this continues in both directions, and then they can have sort of a gate for things to pass through, or a, you know, a donut shape, I guess. They can allow the water to go through in both directions right here. If it just wants passive kind of going back and forth, just through the probability, rather than forcing things through pumps. You can also, you know, I don't know how to draw it really, but going through this bilipid layer, there could also be just sort of a pump to pump ions from one side to the other, or to pump water. If the cell needs to get bigger, it'll pull it in, or if it needs to get smaller, it'll pump it out. And I don't know, I just think it's amazing that just through, you know, chemistry and just making these molecules and arranging them in a certain way, we can have cells that actually have a structure.